Today is day 374 of data science. It is also Wednesday, July 27th, 2022. And today I'm going to do another normal distribution problem because why not? So, you can pause it and read it, but I basically have to find the proportion of exam scores that are higher than Antoaneta's score. And so to figure this out, I'm going to have to, from scipy.stats, I have to import the norm function, and then I can do norm.cdf, and then I can put in my values. And so my x is the point or the number that I'm trying to find the proportion or area above or below. So in this case, that point is going to be Antoaneta's score. I'm just gonna call her Neta's score. So that in that case it's 51. So the first value is 51, and then it's gonna be the loc and the scale. So the loc is a mean, and the scale is a standard deviation. So loc says 60 because it says distributed with a mean of 60 points, and then a standard deviation of 6 points. And I'll just write x over here. Now if I run that, it's going to give me this value over here. It's I believe it says 0.06680. So that is the proportion of exam scores that are lower than Neta's score, because CDF in Python calculates the proportion or the area below a certain point, and that point is x. And so if I want to get the area or the proportion, by the way, they're the same thing, area and proportion, above or higher than Antoaneta's score, I have to use the opposite of norm CDF, which is basically 1 minus norm.cdf. Or I can use the equivalent of 1 minus norm.cdf, which is norm.sf. And it's going to give me the same answer as, 1 minus norm.cdf, right? 0.9332. Now it says to round to 4 decimal places, so I'll do that. So I'll just kind of bring this down over here. This is what I want to round, and then comma, the number of decimal places that I want to round to. I meant to do SF. Let me run that real quick. And then I'll just go ahead and put that in here and check if I'm right. Yeah, so now that that's the answer, I kind of want to further extend and show you a visual presentation of, where's my stuff, of what I'm actually calculating. So for this, I'll import matplotlib, because what I'll do is I'm going to make a graph so that I can clearly see what I'm, the area or the proportion that I'm trying to get here. I'll do numpy as np. So I'll have to plot x values and y values. And then for my x values, it's going to be linspace function. And linspace takes in 3 parameters. It takes a start, an endpoint, and then the values in between. So I guess if my mean is 60, then maybe I want to start with, 40 and end with 80, and then have 1,000 values in between. That's just a guess. It might not be perfect, but I'll fix it later. And then the y values is going to be norm.pdf, right? Probability density function. So that's the basic density function at a certain point. And so the values that go in here are my x values, right? Because I'm trying to find the probability density function of all of the x values. That's going to be my y values, right? And then the loc is, again, it's 60, and the scale is, 6. And now I can just do plt.plot and plot the x values. And then the y values. And that should give me a distribution in 1 second, right? So this is what it looks like, really pretty. And yeah, that's literally it. So I could also just give it a title and be like normal distribution with mu. I could always add this over here. The mu symbol. Where's my stuff? with mu equal to 60 and sigma, which is a standard deviation symbol. Nope. Wait, it's not sigma. What's it called? Oh, it is sigma. Oh, it's okay, yeah, whatever. Okay, and just put that there, and then that's 6, and so that's going to be the title. And then I could also do plt dot y label and set that to proportion. Did I spell that right? And then plt x label. Well, in this case, actually, the x label is, or basically are the scores, right? And then the y is the proportion. So, and I can't even say her name. Neta's score is 51. So at this point, I would just kind of copy the image and I'll just show it in my whiteboard here. So let me lock this. So basically, what I'm trying to find, Neta's score is 51. So it's kind of, right about here. So this is Neta's score, and the question is asking what proportion of the scores are higher than hers. And so what we're really trying to find is the area that is higher than Neta's score, which is literally all of this. This is the proportion of scores that are higher, right, or above Neta's score. And so in order to calculate this proportion, again, I would have had to do in Python. Let me be specific. In Python, if you're using a calculator, it doesn't matter because you specify your boundaries, like the lower and upper, and so there's no need to do 1 minus SF and whatever. It's only in Python where CDF calculates the probability below a certain point. But in your calculators, it asks you for your boundary, so there's no need for that. But over here, right, I would have had to do 1 minus CDF, right? Or I could have just done dot SF. Those are the equivalent. And so specifically, I had to do norm dot SF, and then I would have had to put in my X, and then my mu and my sigma. And so in this case, my X was my point, right? So the X is defined as, well, at least I define it as the point that I'm going to either find the proportion or area above or below it. So whatever they're asking for to find above or below, that's your X. And so that is 51. And then the mu, they gave it to us, was 60, and the sigma was 6, right? And then that should give us, what was it, 93% or something like that? Yeah, 93%, 93.32. That was basically, where's my stuff? Okay, so 93.32% of the students scored, right, higher than Neta, or at least, well, yeah, that's how it pretty much is, or in other words, 0.9332 was the proportion of students who scored higher than Neta, or the scores that were above Neta's score, however you want to word it. But yeah, that's pretty much it. And yeah, the equivalent to this would just be 1 minus CDF with the same values. Is there anything else I want to mention? Not really. If they were to ask the what's the proportion of scores that were below Neta's score, then I would have to find this area over here, and that would just have to be norm.cdf, and it would be the same values, 51, 60, and 6. The only difference is that I'm using CDF, right, which only calculates the proportion or the area below a point, so to the left, while 1 minus CDF, obviously, if I have a distribution and if I have this, right, and I want whatever this is, I can just do 1 minus that, right, because that's going to give me the rest of it. So it's common sense that If I want the opposite, right, if I want the yellow, I would do 1 minus the black area over here. Okay. And then, yeah, that's pretty much it. And then what else? No, that's it. All right. Where's my stuff? Okay, what proportion of exam scores? Yeah, so 93.32% of exam scores were higher than Neta's score of 51 points. All right, which makes sense, right? Because usually not a lot of people score 51, so it would make sense that a lot of the scores are higher than 51, right? All right, yeah, that's pretty much it then. Bye.